Next exercise 1.2. First question. Function from R stars to R star. Definition is this. Here R star means all real number other than 0. 0 nil and I. So this can be negative or positive. You want to show that this is what we want to show. We show that f is both 1 1 and on 2. F is 1 1 and on 2. I forgot to mention this in theory part. A function which is both is called bijective. Bijective function. Bijective means it is both 1 1 as well as on 2. Such a function is called bijective function. So you want to show that this is bijective. Means you want to show that first it is 1 1 and then second it is on 2. Okay, so first part 1 1 function. So how we'll do? You know, two ways. You start with this. Suppose x1 is not equals to x2. What is x1 and x2? These are the any members of the domain that it belongs to R star. You want to show that f of x1 is not equals to f of x2. This is what you want to prove. So if I can show this, so for every x1 x2, what you are going to show here, whenever x1 is not equals to x2, it implies f of x1 is not equals to f of x2, and therefore f is 1 1 function. Now here intermediate step. What is f of x1? Just go back to definition. Is it 1 upon x1? What is f of x2? 1 upon f. Here, let me write here. What is f of x1? It is 1 upon x1. What is f of x2? It is 1 upon x2. This much you know. Now if elements are different, you take the reciprocal on both the sides. If numbers are different, obviously their reciprocals are different. This is obvious. This is the only important step. Here you have started with the numbers are different. If numbers are different, their reciprocals are different. Now recall, what is 1 upon f of x1? 1 upon x1, that is f of x1. What is 1 upon x2? That is f of x2. So therefore you have this, and therefore it is 1 1. Or you can do this way also, or whichever you like. Remember, suppose you have this f of x1 equals to f of x2 for every x1 x2. Now write the meaning of f of x1, that is 1 upon x1. Write the meaning of f of x2, 1 upon x2. Take the reciprocal on both the sides. So x1 equals to x2. So what you have shown, whenever you have f of x1 equals to f of x2, it implies x1 equals to x2. And this is true for every x1 x2. And therefore f is 1 1. So choice is yours. Whether you use this concept or this concept, both are having the same meaning. Remember, you started with different members. You have shown that images are different. Here you started with their images are equal. You have shown that the elements are equal. So then in that case also f1. In any one of these two, either you use this or you use this, not both. Remember, this was the first example, that's why I've shown. But it's not necessary. Whichever you feel easier. In some examples you can use this if you feel easier, or you can use this. Choice is yours. So next on to part. So if I take different members from the domain, suppose I have taken 1, so image is 1 upon 1 1. If I take 2, then 1 by 2. If I take 3, 1 upon 3. If I take minus 4, minus 1 upon 4. If I take 1 by 2, here you will get 2 reciprocal. For example, if I take minus 1 upon 4, so answer will be minus 4. If I take root 2, the answer will be 1 upon root 2. If I take 1 upon root 3, answer will be root 3. If I take minus 10, answer will be 1 upon 10. So you can see that in the range, you are getting all numbers, all real numbers in fact. Negative numbers, positive numbers, integers, irrational. So you can predict from this that the range is range RF equals to all real numbers, and you have not chosen 0. All real numbers other than 0, which is as per the notation given here R star, which is same as codomain. So f is onto function, f is onto here. Range of the function equals to codomain. You will get all numbers here other than 0. You see, every numbers you can find, all real numbers can be obtained. Suppose if I want here 1000, so you take f of 1 by 1000 here. So you'll get 1000. Every number you will get on the right hand side. That is all real numbers. That is R star, which is codomain, and therefore f is onto. Or alternatively, this is another way of doing. What we do, we start with this. For every y from the codomain, R star, remember, this is codomain. For every y in this, we find x. Now how to find that we'll see. We find x such that, I'll tell you how to find this x, such that if I find f of x, if I apply the function, so at the end my answer should be y, and then f is onto. This is theoretical method, right? This would be again very important method. If the function is defined on real numbers, usually this technique is used. If you understand it, this is easier than this. This technique is used only when you have domain and codomain as n, z, and so on. Then this will be easier. But this is also very important method. Later on you will realize to find the inverse of a function. Now how to find this x? So you take one example, you will realize. You see, if you want here root 3, here you are choosing 1 upon root 3, so you are getting this. If you want 2, you are choosing 1 upon 2, so his image is 2. Suppose I want here 20, so what I choose on the other side, 1 by 20. If I need here, for example, let's call 7, then I should choose 1 upon 7. So here I've started with this 7, which is y, for example, 20, that is y. Then I'm taking 1 upon 20, here 1 upon 7. So what should be my x? That is 1 upon y, reciprocal. And remember, x will be again in R star. It is non-zero. Right. This is just by observation, reciprocal. You will realize later on also. Now, this you have defined, remember, based on the function. So x equals to 1 upon y. Suppose if I have taken 7 here, I'll take 1 upon 7. Then f of 1 upon 7, that is f of x. Now what is the definition of fx? That is a reciprocal. So f of 1 by y, I have placed the value of x. Now what's the definition of the function? 1 upon this number, that is 1 by y. 1 upon 1 by y. So this gives us y, and therefore f is onto. Question number 2, first one. F is a function from n to n, where fx equals to x square. Now when domain is n or z, usually tasks become easier. So here first one part, you're asked to check whether it is 1 1 or not, or onto or not. That's the question. We want to check whether it is 1 1, that is injective, or surjective or not. So 1 1 part. So here suppose if I start with this, x1 is not equals to x2, then obviously the squares are different because numbers are positive. For every x1, x2 belongs to the domain, remember. This you know. If numbers are different, their squares are different. Now what is f x1 square, which is f of x1? What is this f of x2? Of course they are different, and therefore here what you have shown, whenever elements are different, their images are different, and this is true for every x1 x2, for every x1 x2 in the domain, remember, belongs to natural numbers. So therefore f is 1 1. Now here by just observation you can see, if I start writing members, if I write f of 1 1, if I write f of 2 4, तो देखो 2 and 3 आया ही नहीं. If I write f of 3 directly, you are having 9. If I write f of 4, you have 16, and so on. So what you have noticed here, range RF equals to perfect squares, number 1 4 9 16 and so on. Is it same as codomain, that is n? No, this is not equals to codomain. What is the codomain? Which is n, natural numbers. So therefore this is not onto function, not onto. What's the reason? Because of this, as you have this. Now no need to give any proof in such case, just by observation you got the range here. To get the range in case of n or z, task become easier. So if you have domain as n or z, you can get range directly and you can notice. So here range of the function are this number 1 4 9 16, whereas codomain is n, and you know that this is not equals to n, so not equals to codomain, therefore it's not onto function. So this is 1 1 but not onto. Next function is z to z, all integers, and fx equals to x square. So just by observation if you notice, what is f of 1 1, what is f of minus 1? You know minus 1 square, which is 1. So what is your conclusion from just this much? Not 1 1, finished. Not 1 1, not 1 1. You are through here. You could find two different members having same images, that is 1. So this is not a 1 1 function, not a 1 1 function. Now range, you know, in this case, if I try further some example, f of 2 4, f of minus 2 4, f of 0 here 0, and so on. So if I write the range of this function, you know it is 0 1 4 9 and so on. This is the range. Is it same as codomain? No, here codomain is z, this is codomain. Second set, here second set is z. So therefore what is your conclusion? Not onto. So this is a function which is none of these two, neither onto nor 1 1. This is also called many one function, remember. Not on 1 1 means many one. So this is neither 1 1 nor onto. There are 3 more examples. If I go for one more, third one, f from real numbers to real numbers. All these things you did in 11th, you can just recall here. Real numbers to real numbers. Here domain and codomain are R, their domain and codomain were Z. So here you can take the same example of these two numbers. F of 1, 1 square, which is 1. F of minus 1 square, which is 1. Elements are different, images are same. So from these your conclusion is f is not 1 1 function. It's not a 1 1. One example is sufficient, remember. You can give if you want some more, but just one example is sufficient. Here 1 and minus 1 are different, but their images are same. So this is not a 1 1 function. You know from 11th standard, if you recall, range of the function. So here range RF you did in 11th. It is, if you remember, R plus union 0, all real numbers with 0. Is it same as 11th standard, recall from 11th. You can prove it also. Try to prove it why range is this, which is not equals to codomain. So f is not onto function, not onto. F is not onto, neither 1 1 nor onto. Now take this function from real numbers to real numbers. You know that this is that floor function or box function, if you remember 11th standard. Right? You just recall the value is the least integer less than or equal to that number, you know. So here, if you recall, in this case, the box function, that's the first integer from left side. First integer from left side, you know this one. First integer from left side. So if I take here, suppose 1, then box of 1 is 1, you know it. If I take 1.5, then box of 1.5, you know it is 1. ये आप जानते हैं, you know all these things. So from this, immediately what is your conclusion? Not 1 1. This is not a 1 1 function. Even you can choose f of 1.4, which is box of 1.4, which is also 1. Even if I choose 1.3, you know that box of 1.3 is also 1, and so on. But this just one example is sufficient. Members are different, but their images are same, so not a 1 1 function. This is highly many one function, remember, many one function, not a 1 1 or many one function. If I go for 2, you know it is box of 2, it is 2. If I go for 2.9, you know box of 2.9 is 2. If I go for 0, you know box of 0 is 0. If I go for -1, you know box of -1 is -1. If I go for -1.5, if you remember, box of -1.5 is -2. If you just recall, if this is a real line, this is 0, this is -1, -2, -1.5 is here. So first integer from left side is this, -2. If I take this as 1, this as 2, here for example this is 1.4. So box value is 1, first integer from left side. All these things you know. If I go for 100, box of 100 will be 100. If I go for f of -5, box of -5 is -5. So here the word itself says in the definition, answer should be an integer. So all these are the integers. So range, that also, if you recall 11th standard, is Z, all integers. It is not equals to codomain. You know this much even from 11th standard. Range of this box function is Z, which is not codomain. So not onto function. This is not onto function. Not 1 1 as well as not onto. So next, f from R to R, fx equals to modulus x. Now this is also very well known. If I take f of -1, you know modulus of -1 is 1. And if I take 1, modulus of 1 is 1. So what's the conclusion from this? Many one function. Many one function. I mean not a 1 1. Or you can say that it is not a 1 1. Not 1 1 function. You know this from 11th standard. All these things are from 11th. You also recall range of f here, that is Rf, is always R plus union 0, 11th standard, which is not equals to codomain. What is codomain here? All real numbers. So here f is not onto. F is not onto function. If you want, here you can give just reason here. at this place y range, you can give this reason as modulus x is always greater than or equal to 0. So RF will be greater than or equal to 0. That is positive real numbers with 0. If you want, you can write like this: 0 to infinity. You know this also. Close interval 0 to infinity. Every positive real number with 0. That is RF is this, if you want just. So not on to. Question number 5 here, which is also a very simple function. If x equals to 1, if x is greater than 0, 0 if x is 0, and minus 1 if x is negative. You know this is called, again 11th standard, this is called signum function. This is called signum function, 11th standard. Signum function. Signum function takes only 3 values, you know, 1, 0 and minus 1. So obviously range will be here, range of this function will be just 3 numbers. Is it same as codomain? No, it is not same as codomain. Codomain is R. Look at the definition. Codomain is R here. Here codomain equals to R. So this is not same as codomain. So not onto. Not surjective. Remember, onto means subjective. It's not surjective. Not surjective. And obviously, if I write f of 1, it will be 1. If I write f of 2, it is 1. If I write f of 100, again it is 1. For any positive real number image is 1. So from this, what's the conclusion? Not 1 1 function. Not 1 1 function. This is highly many 1 function. Not a 1 1, not on 2, remember. Question 7 first. This is an important example. F from R to R, fx equals to 3x minus 4. This is a linear function from R to R. You know, it is linear function. Linear function from R to R. This you know. Now here domain is real numbers, so it's very difficult to take all numbers and to check whether 1 1 or not. So here I'll give the proof as I gave in the first example. So 1 1 function. So I'll start with this. Suppose f of x1 equals to f of x2. Started with equal images for every x1 x2 in the domain. And what I'm going to show, I'll show that x1 equals to x2. Remember. Now write the meaning of f of x1. So 3 minus 4x1. Write the meaning of f of x2. 3 minus 4x2. What is f of x1? 3 minus 4x1. What is f of x2? 3 minus 4x2. 3 will get cancelled. Minus 4x1 equals to minus 4x2. Minus 4 will get cancelled, so we'll get this. So what you have shown, whenever f of x1 equals to f of x2, it implies x1 equals to x2 for every x1 x2 in the domain, remember. And therefore you have shown that f is 1 1 function. 1 1. So this is one part. One is this. Second part, that is onto-ness. Now if you recall from 11th standard, range of any linear function from R to R is R. So it has to be onto. So I'll give the proof. Which proof? That is that alternative proof. So I'll start with this. For every y in the codomain, we find x. Now I'll tell you how to find x. We find x, some x, find x such that, I'll tell you how to find this, such that when I find f of x, I must get y. So what you have concluded finally, for every y in R, there is x in the domain such that fx equals to y. and therefore f is onto. F is onto. Now this part I need to show here. How do I show? So what you have to do usually in such questions, you to find x, you take the function equals to y. This is a method. Take function equals to y. Now write the formula of the function. What is the formula of the function? 3 minus 4x equals to y. And now you make x as a subject of the expression. So what I'll get here? 3 minus y equals to 4x. And therefore I'll get x equals to 3 minus y by 4. This is a way of getting x. This much you can show inside in the exam also, as I've shown here. I'll repeat. Take fx equals to y, write the formula for function, and make the x as a subject of the expression from this. So I'll take 4x on the other side, y this side. So 3 minus y and this. So what is my x now? 3 minus y by 4. This is also a real number, remember. How I got this, that I have explained. Such that, now come to this. F of, put the value of x, that is 3 minus y by 4. Now write the formula for function. What's the formula for function? Formula for function is this, 3 minus 4x. So I'll get 3 minus 4. Instead of x, you are going to write this bracket. That is 3 minus y by 4. You simplify this, you will get exactly y. 4 will get cancelled, 3 will get cancelled. So what you have shown, fx equals to y. So for every y in the codomain, there is a x such that fx equals to y. And therefore, you can say that it is the onto function. So this is a standard way of proving ontoness for linear function from R to R. If it is asked in the exam in subjective, you need to do this much. In MCQs, you can write directly, this being linear function from R to R, it is always onto and it is always 1, 1. So this is a bijective function. So I'll note here, every linear function that is a function of this type, ax plus b, you know. Every linear function from R to R, from real numbers to real numbers, is always 1, 1 and onto. That is a function which is 1, 1 and onto, it's called bijective. So this is a bijective function. Every linear function from R to R, linear means this, for example this. If your function from R to R, real numbers to real numbers, remember. And if I have x equals to 2x plus 1, 4x minus 1, 7x plus 2, all are linear functions. These functions are always bijective functions, remember. Bijective functions means what? 1, 1 and on to both. These all functions are bijective. Now I'll go to 7th question, second one. F from R to R, real numbers to real number, 1 plus x squared. This is a quadratic function. So here one thing is quite obvious. If I write f of 1, it is 1 plus 1, which is 2. If I write f of minus 1, it is 1 plus 1 again 2. So what is the conclusion from this 2? Not 1, 1. Not 1, 1. That's quite obvious from this. Even if I take 2 and minus 2, it will be 4 and 4. So two different members are having the same image, so not 1, 1. What about onto part? You know how to get the range of such functions. So you recall x square is always greater than or equal to 0. I need 1. This is from 11th standard. Greater than or equal to 1. Now what is this? This is fx. Fx is always greater than or equal to 1. So you can say that range means fx. Range is 1 to infinity. Close interval 1 to infinity. All numbers greater than or equal to 1. Is it same as codomain? No. Codomain is R. Codomain is R here, all real numbers. So therefore f is not onto. Not onto. Whenever you are saying that not on 2, you need to show that the range is not equals to codomain. 1 1 part, one example is sufficient. So not 1 1 here, because here two different members are having the same image. So not 1 1, not on 2.